Hello class, this is Dr. Valenzuela, and I wanted to go to Module 7 and walk you through the technical aspects of the 7-3 Project 2 assignment. Now this is a very technical assignment. I'm only going to cover the technical aspects of it, and you'll need to click on this requirements and rubric for the directions. Now remember, for the project, you're going to have to address every bullet point that you see in the project. So for every bold header, make sure you address every bullet point under the bold header. For instance, under the purpose, you have you have the question, and then the bullet point A that you have to address. So all these bullet points have to be addressed in your analysis and in your report. You're going to be submitting this Project 2 template for the assignment. Now, when you work on the assignment, I'm going to move this down here. Make sure you click Enable Editing. As soon as you complete a section, make sure you delete the instructions. Okay? Make sure you delete the instructions from it. Okay. Now, let's take a look at the instructions themselves. And you have been hired by a regional real estate company to determine if your region's housing prices and housing square footage are significantly different from those of the national market. The regional sales director has 3 questions that they want to see addressed. Are the housing prices in your regional market higher than the national market average? Is the square footage for homes in your region different than the average square footage for homes in the national market? For your region, what is the range of values for the 95% confidence interval of square footage for homes in your market? Okay, you're given a real estate data set that has houses listed in every county in the U.S. In addition, you have been given national statistics and graphs that show the national averages for housing prices and square footage. Okay, you'll be using the Project 2 template to submit everything under the directions and under the bullet points need to be addressed. Okay, so let's take a look at the data. Here's the data set. Now remember, when you're working with Excel, move this down here, make it bigger. Make sure you click Enable Editing so you can copy and delete. Okay. And so we've got West, South, Central. So I see that here are the areas. So if you look at these areas down here are the different regions. New England. I live in the Seattle area, so there's the Pacific area. Okay. And so you'll hit these tabs to pick a region. Let's keep going here. Okay. Okay, going back to the instructions, we also have this. So we have the housing list price by region, which is the Excel file that I just opened. That's this one. Then we have the national statistics file. Okay. has the mean, median square foot. Okay, here's the mean, median, okay, standard deviation. Okay. Okay, let's go back to the project directions. So it has here that real estate data set that has houses listed for every county. In addition, you're given a national statistics and graphs that show the national averages for housing prices and square footage. Okay, good. Okay. Okay, so the first technical part of this is there's a one-tailed test. Now, what I'm going to do in this particular case, I'm going to do something similar to what I did in the prior video for the prior project. And I'm going to run, I'm going to do a t-test with a dummy column of data to run the one-tailed test. Okay. And let's take a look here. Okay. This looks good. Okay. Now let's take a look at the national data. So here, the median square feet, median the median cost per square foot. Here's the mean, 142. Okay, median list price. Okay, good. All right, so average. Okay, average is 142 here. So I think what I'm going to do is I'm going to use this as a basis for my analysis. Okay, so I'm going to use this mean value for the cost per square foot at 142. This is the national average. So when you, and let's go back to the directions. So you'll have to define the population parameter. In my particular case, I'm going to use the Pacific region. I live in the Seattle area. And I'm going to select, let's just say I pick 50, randomly pick 50 data items. And let's say it's the first 50. So 56, there we go. Okay. Copy that over to the right here. Okay, so I can work with a new set of data. There we go. Okay, so here's my population as a randomly selected 50 data items from the Pacific region. Okay, now as remember, you'll have to define the hypothesis, right, for a one-tailed test. And so I'm going to use the, as I mentioned with the directions, the mean or the average cost per square foot. Okay, so that's what I'm going to do my analysis on. So I'm going to insert symbol. This is the mean symbol, mean value. Okay. Average. Okay, let's go back to my file here. Okay, here's the cost per square foot here. Okay, got it. Okay, so the way I'm going to define the null hypothesis, h sub 0, this is the null hypothesis, is equal to the mean is going to be less than or equal to okay, 142, the cost per. Now, the null then I'm going to say is the mean is less than or equal to the cost per average cost per square foot nationally. Remember that in the national data, the mean or the average cost per square foot 142. Okay, and so what I am going to use is okay. So what I'm going to do is I'm going to use 142 as my in my hypotheses. So now I'm going to do the null hypothesis. I mean, that's the null. So this is the, we would consider this the null hypothesis. Now I'm going to do the alternative hypothesis. Okay. H sub A is the alternative. What I'm going to do is I'm going to switch this symbol to be greater than. Okay, I'm going to use the greater than symbol. And it should be, oops. This one here, greater than. Okay, there's my null and alternative hypotheses. Now, I have to, my next step is to calculate p-value. Okay, and I'm going to use, as I mentioned, a t-test. Okay, and what I'm going to do is I'm going to use a t-test, but with dummy data in the second column. Okay, so the first column of data is going to be the cost per square foot. So that's this column. I'm going to copy that here. Okay, and then I'm going to use my dummy data, which is 0 and 0. Okay. Now, the t-test I am going to use, I'm going to use down here. So what I'm going to do is I'm going to use data analysis. I'm going to use a t-test, as I mentioned, this one, the t-test, with a two-sample assuming unequal variances. So it's a t-test two-sample with assuming unequal variances. And this will allow me to run a one column hypothesis test with dummy data in the second column. Okay, so I'm going to use labels, which means I'm going to put in these two labels here. The hypothesized difference is going to be the hypothesis, which is 142. Okay, is the difference in the hypotheses difference. Okay, and then my first data value is here. Okay, make sure that you enter the label, cost per square foot. The second data is here. Alpha significance level of 0.05. I'm going to put my output. Make sure you click on output range, click in the output range box, and I'll put my output here. Hit OK. Okay, there's my output. Move this over a bit. Okay, now we're going to move to the right. So I ran a t-test two-sample in data analysis, assuming unequal variances. So this gives me a hypothesis using a single column of data with dummy data here. Make this column bigger here. One-tailed test p-value is 1.9. It's home. Make that yellow. Okay, so when you see this 1.09 e to the negative 7, that means you're going to move the decimal place from here 7 places to the left. So basically what you have here is a p-value is equal to 0. Okay. So we have a p-value equal to 0. Well, let's go back to our hypothesis here. So we have, so when you're doing this, I need to see the output of your analysis. So you actually need to, copy this part, copy it into the Word document so I can see your analysis to get full credit. Okay, so there's the analysis there. Then you can 0. Now, in this particular case, right, you have, remember with p-value hypothesis testing, if the p-value is less than 0.05 or the significance level, then you reject the null hypothesis and accept the alternative hypothesis. Okay. If the p-value is bigger than 0.05, the significance level, remember the significance level can be different than 0.05, but we're using 0.05 here. Then you reject the alternative hypothesis and accept the null hypothesis. In our case, we have that the p-value is equal to 0 Okay, class, so our p-value is 0. Therefore, we can conclude that the p-value, um, I'll just copy this, the p-value is less than the significance level. And I forgot to mention, we typically use a 0.05 significance level, and I just assume that, but you also need to state that you're using a significance level, calculate the p-value here, and use a significance level of 0.05. Okay. Now, so we're going to accept the alternative hypothesis, which is this hypothesis here, that the mean average cost per square foot okay, so this here, that the average cost per square foot is bigger than 142. Okay, that's what that one column analysis was about. Okay, so remember, you have to address all these bullet points here, and then you'll make sure that you address everything under this. Now, in this particular case, now we're talking about a two-tailed test. With a two-tailed test, you basically are going to use two columns of data. Remember that you're going to do a histogram also in this part. I'm not going to show you how to do the histogram. Remember that in my announcements, there's a lecture videos on doing statistics with Excel. You're going to want to use the video on histograms here. Okay, if you don't like this one, there's others in YouTube, but this is a good one on developing a histogram. Okay, so two-tailed test. Now, define the population parameter. Okay. Let's, one of the things that we're going to have to do here is our housing prices in the regional market are higher than the national market average. Is the square footage for your homes in region different than the average square foot homes in the national market? Okay. What is the range of values? Okay. So in this one here, one of the things you're going to use is using the this one here. You're going to do data analysis, but you're going to use the tool that we've used before, which is the descriptive statistics tool. So you're going to use data analysis, and then you're going to go to descriptive statistics. And this tool, descriptive statistics, will give you the mean, median, and mode of your data. And make sure you copy that output into the report when it's asking for summary statistics. Okay. Let's go back here to the instructions. Okay, so one of the things that I think when you do a two-tailed test, I think you have to be careful here when you do this histogram, because when you're using two columns of data for a two-tailed test, do the histogram only of one column of data. You don't want to combine it, okay, because that can be very confusing for the person analyzing the data. Okay. Provide at least one histogram. Now, if you want, you could do a histogram of both of each column of data. Remember, for two-tailed tests, you're using two columns of data. Let's look at our data first of all. Okay. There's the cost per square foot here in my data. Housing prices. Okay. Okay, so this is the cost per square foot. I'm going to edit up here in the Pacific region. Okay. And what I'm going to do is I'm going to compare that with the mountain region. Okay. So I'm going to take cost per square foot of the mountain region. So I'm going to take 50 data items here. Okay. And I'm going to go back to my Pacific column. And I'm going to put this there. Now make sure you have the same number of data items, and I do. There should be about 50 in there. So this is the cost per square foot in the mountain region. These are, so basically for a two-tailed test, you need to, I'm going to use um, two columns of data. Okay. And okay. Now, I've got the cost per square foot of the mountain region and the cost per square foot of the Pacific region. Now, two-tailed test, what I'm going to do is I'm going to set up the null and alternative hypothesis. I'm going to do it a little differently. I'm going to use a two-tailed test. So where's the two-tailed? Here's the two-tailed test. Okay. So the two-tailed test. Oops. For the two-tailed test, I use cost per square feet. And what I'm going to do with the two-tailed test is I'm going to write it in this manner. And I want you to do the same on your project. And for a null hypothesis, that means that there is no significant difference between the mountain and Pacific regions in relation to the cost per square foot. Okay? And then for the alternative of this, there is a significant difference between the mountain and Pacific regions in relation to the cost per square foot. Okay. That. Now, we have to calculate the p-value. We're going to use significance level of 0.05. So now what we're going to do is we're going to use a t-test with 2 columns of data. Okay, so I don't need this dummy data anymore. Get rid of that. I don't need this test anymore. We did this test already. I'm going to delete these columns. Delete entire columns. Okay, good. Now I'm going to run a t-test. So I'm going to click on Data, Data Analysis. It's going to be a t-test paired two-sample for means. Hit OK. I'm going to include the labels. The significance alpha level is 0.05. The first data range is here. Input that. Second data range is here. Okay. You don't have to put a hypothesized difference because we're not using a hypothesized difference value. Click on Output. Click in the Output range box. I'm going to put the output here. Hit OK. Here's our output. And here's the two-tailed test there. Click Home. I'm going to color that yellow. Now notice this e to the negative 0.05 means that you need to move this decimal place 5 places to the left, which basically means p is going to be equal to 0 in this case. Okay, so I'm going to have p equal to 0. Now, p is equal to 0, so therefore we can go back here. So we have p, the calculated p-value is 0, okay, which is less than the significance level. Therefore, accept the alternative hypothesis and reject the null hypothesis. So we can therefore say thus, comma, this is true. There is a significant difference between the mountain and Pacific regions in relation to the cost per square foot. Okay, that's what a two-tailed test will tell us. Now, let's go back to the instructions here. Now, remember with the data analysis, you're going to do your summary statistics using the click in Excel, clicking on data analysis, and use the descriptive statistics tool. Okay, for summary statistics, you'll do the histogram. Okay, you have to address all the bullet points. Remember that. You got to address whether it's normal or not. The test statistic. This is the t-stat value if you need it in the t-test, paired two-sample for means. There's the t-stat value, but we don't. You can list it, but we've already calculated the p-value, so you don't have to recalculate the p-value. Okay, calculate now. Comparison of the test results. Now, when we're going to do this, I'm going to do this part here, calculate a 95% confidence interval. We need to do the calculation on the Pacific region. Okay, so I'm going to do it on the Pacific region. Okay, so that's what I'm going to focus on. So I'm going to show you how to do a 95% confidence interval calculation. Okay, so the first thing we need to do is we need to calculate the summary statistics. So click data, data analysis. Oops. So I'm going to calculate 95% confidence interval. Okay. So I'm going to click data, data analysis. I'm going to use descriptive statistics. I'll use labels, summary statistics. And I'm going to do the confidence. You have to click on confidence level for me, 95%. Click summary statistics. Click the input range. The input range will be the cost per square foot of my region, Pacific. I'm going to click on the output. Put the output here. Okay, so here's the output. And what I'm interested in is this value here. Now I'm going to do a right click. I'm going to format the numbers to just one decimal place. And I want the mean. So I'm going to highlight that yellow. And I want the confidence level. So the mean that I calculated for my cost per square foot is 281.6. Okay. I'm just going to copy that table into Word because I do need it. So to calculate the 95% confidence interval, I need the table. So I'm just going to go to the next page because that way you can see what I'm doing. Okay, so the mean is 281.6. So to calculate the confidence interval, it's going to be the mean, 281.6, minus this confidence level number, which is 40. This is also this is called a margin of error. Minus the margin of error, which is a confidence level number of 46.7, will be less than the generic mean value. Will be less than 281.6, the mean, plus the margin of error, which is this number down here, 7. Okay, so I'm going to calculate that. Hold on one second. I'm just going to use my phone here. So I've got 281.6, 281.6 minus 46.7. Is 234.9. So I'm going to copy this down here. So on the left-hand side of the interval, it's 234.9. On the right-hand side, it's 281.6 plus 46.7, which is 328.3. Okay, so this is the 95% confidence interval of my Pacific region cost per square foot. Okay. Now, so it's telling me that if I sampled 95 out of 100 cost per square feet in my region, different counties, whatever sampled in my region, the mean value should be between 234.9 and 328.3 in the cost per square foot in terms of dollar size. Okay, so now let's compare that to, remember that, so we did the 95% confidence, or interpret the confidence interval. Now, the mean cost per square feet here is 142. And you can see that the national average of 142 cost per square foot of 142 is nowhere near the confidence interval of my Pacific region cost per square foot. So basically what that's telling me is that as I'm sampling this, that the there's certainly other drivers that are driving these high cost per square foot values in the Pacific region that are not being driven in the national cost per square foot figure of 142. Much of that, because I live in Seattle, the Seattle area, I can tell you that much of the driving costs are the high cost of living. We are also next to the ocean. So when you live next to the ocean, just like San Francisco or San Diego or some of these areas where you live next to the ocean, and you have oceanfront viewing and all that, the costs are going to be significantly higher than if you are living inland or in the middle of the country, right? So there are significant differences between our confidence interval, the mean values that we're finding in the sampling of the Pacific region versus what we're seeing nationally. And we're definitely seeing, and I can attest to the Pacific region, how high the cost per square foot is in the Seattle area, for instance. Okay, so these are the technical elements of this project. Remember that it's very important that you address all the bullet points in the project. Use the template, show all your work in the template so I can follow your thought process and I can see how you calculated everything. That's very important. Okay, so have a great week, and I look forward to working with you this week. This is Dr. Valenzuela.